EasyCTF is on. Well, I think this is wonderful. I highly encourage you to do it. If you aren't doing it, you're missing out. I think this is the most fun one ever. I'm having a good time on a team with me and one of my ex-students, and we got almost all of them. I'm down to just the last few. Yeah. So we made it past 1,000. And we're just a few of the big ones are still going here now, but I've learned a lot. These are very good. They'll turn into homework. I'm not going to demonstrate them, but some of them will belong in this class. There's a series of them where you have a web page and you're trying to log in, and you have to try to figure out what the password is from the source code, and he makes it harder and harder to see the source code. And I just got so those will probably make good homework for this class. I'll just wait until it's over before I make it into homework. There's another one that's a lot of fun. I definitely want to put for homework in this class. There's a server, and you have to do a timing attack to find the password, which there's already a version of that in this class. I'll probably make a version of their server and set that up. This is a very common cryptographic side channel. You measure how long it takes to respond to things, and from that you can deduce whether you're right or wrong. And now you guess. But anyway, it's so check it out, and it's worth extra credit if you do EasyCTF in any of my classes. It's free. Make an account. I just work alone is fine, or work with just a pair of people. If you're in a big team, it's not much fun because the other people do all the easy problems, and then you're stuck with the hard ones. You should at least get a chance to do the easy ones.
Should we just like submit a screenshot of the completed ones for
to get extra credit, just let me see a score or something like that. Your score shows up here.
Yeah.
Say like your name and the score, that would do. Yeah. And I'll yeah, that's great. It's worth extra credit. Any of my classes. This is just like homework. It's just a more fun way to trick people into doing homework. I just proposed a whole bunch of talks today, 2 at Hope, hands-on workshop, 2 at Hope, 4 at DEF CON, 3 at DEF CON so far. I'm going to give 2 at B-Side San Francisco, all over the place. And they're all CTFs like this, because that's what people have fun doing. Yeah.
When you mention it's extra credit for a class, could it be applied multiple times, or?
Well, you can only use the points once, but if you solve a lot of problems, you can put some points here and some there.
Okay.
Yeah. And I think the total amount you can get from a CTF like this, I'll figure out some system, but you can certainly get at least 40 points and maybe 80 if you get a lot. I'd say anybody gets 1,000 points should get maybe 80 or 100 points. Put it anywhere you want. Because this is just like doing a whole bunch of homework projects without instructions. It's just as valid as any of the homework assignments I'm giving you. And it's really better because this is the real state of the art. And if you find some way to get help, like from another student or a blog or something, that's fine too. In the homework projects I give you, there's instructions. So I think this is very good. So here we are. Today it's client-side controls and Gesundheit. This is pretty easy. So it is important to know how to do this. As we've been over in the earlier lectures, there are a lot of foolish things in the way people typically design web apps. And almost all of them come from a confusion on the part of the developer about where the process is happening, or just an unawareness of the importance that they shouldn't trust anything that happens on the client. And therefore, to do proper pen testing, you should learn how to do nasty things from your client. The developer, of course, will probably do something like assume that all the client does is open the web page in a normal browser and use that browser. This is like we were talking in another class about the cryptographic USB sticks. The first generation of protected USB sticks were not encrypted. They just put an app that launched when you plugged them in on Windows that asked you for a password and wouldn't let you see the stick unless you put in the password. But it wasn't actually encrypted. So if you plugged in Linux and used a forensics tool, you could see the data. And my first thought when I first heard is these guys are idiots, they're ripping people off, it's not really encrypted. And then I thought, well, you know, it's actually got a defense of a sort. They've stopped one attack. They just didn't stop all the attacks. And so if you're the person who designs a safe USB stick assumes that the only attack you know how to do is to plug it into a Windows machine and hope to like open it in my computer. And if I stop that, I've therefore protected you. And the developer in the same way assumes that the customers are just clicking a link, opening my browser, and clicking the links I put on the page, so I make it so it works under those conditions. And they're not aware that the customer could be doing something nastier. So they often, turns out, they often choose to take data and send it to the client, and then have the data come back in a future request and assume it hasn't been changed. It is more convenient for the developer to bounce the data off the client and back up to another server than to move from one server to another up here, which would be a lot safer. And this is often because of the chaos at companies, because you have many different machines and many different protocols. So when first this sounds ridiculously stupid, why would you do it that way? But this is often the easiest way to do it. For example, you might have a shopping site and then you have people putting ads on the site and they want to know some demographic information from the people. So you'd like to know something out of the user profile. The easiest way to do that is to put it in a cookie and have the cookie sent to them. Sending it to them directly and somehow correlating it with the viewer is complicated. So it's often easier for you to bounce it off the client to get it to the other server. But of course that does mean clients could mess with it. But you probably think that isn't going to happen very often and maybe it doesn't matter and stuff. And this is where you have the slippery slope, because the first developer will do this and say, well, it's just a targeted ad, who cares if they manipulate it. But then some later developer will take this data and put it in something really important, like purchasing or making your credit card count, and not realize that the origin of that data was from this unsafe practice. So you end up with stuff being trusted that shouldn't be trusted. But that's the game here. So instead of storing data on the server in a session variable, which is the secure way, it's often much better in complicated situations with many servers to do this. And the issue may be administrative, where you are on the team to make the server for the mobile device, and you are not authorized to change something about the server over here that has to do with the enterprise client and the advertising. And you can't get approval, so the only thing you can do is put something in a cookie that was seen over there. You can't really open some new kind, alter something about that other server without waiting for approval and bothering people that are too busy and all that jazz. So one thing you have to put that data someplace. One place you can do is put it in a form field. So here a person is buying something and they want to buy one and submit, and this price has to get to the server somehow. So one thing people often do is put it in here in a hidden field. You can have a hidden form field in the HTML, and now when you click the submit button, that data will be sent to the server from the client, but it does not appear here in a way that it can be modified. So this is, people will generally assume that you can trust that price, but of course you can't, because the user could modify it in Burp, or they could save a local copy of the HTML, edit it, and use the modified form. They could intercept it with hardware on the way to the server. In the router, there's many possible ways they could alter that data. And so you can do it in Burp. So let's set up, there's a homework where you do this stuff. And I know this one's going to work because I just went through it all to prepare for this lecture. So let me go to this one. This is attack samsclass.info. Okay, and you've got to go through Burp. This is, you have to get your Burp trusted. Let me get out of this junk and go to proxy. Clear me history. Okay. And what I've done here is I have exported the certificate and put it in the browser here. So the first time you go to a secure page like this one, HTTPS, it will tell you there's something wrong, there's a man-in-the-middle attack in progress, and you have to confirm security exception to get here. So I've approved a security exception so I can man-in-the-middle HTTPS stuff, so I can go to this client-side controls demonstration. All I've done here is make a page that demonstrates these things. So if you want to buy one iPhone, you click submit and you get an iPhone for 449 bucks. But you want to buy a phone for 50 bucks. And you can't do it just directly in the browser, but you can easily do it in Burp, of course. Now the way to do it that is directly the way I put it in the instructions for the project, let me demonstrate that first, and then I'll show you the more fun way, which I didn't know about when I wrote this project. The simplest way to do this is go to intercept. Simplest conceptually, but most difficult in practice. Turn on intercept. Now, by the phone, and now what Burp does is it grabs the request on the way out and does not send it. The reason why this is unpleasant in practice is usually you have all kinds of other things going on in your browser, updates and checking for things. So when you block intercept, you don't get the right request, and you have to hunt through the request trying to find the right one. That's why this is only good in an artificial situation where you have a special browser that's really doing nothing else with no plugins and all that. So anyway, now this is on its way out to the server, so now I can modify it before it goes there. You can just double click on this and change it. Should be able to change it. There we are. So I can change that to 50. Now I can turn off intercept to just let it all go through is one simple way. And now I bought a phone for 50 bucks. So that's one way to do it. And this is how I used to do it, and it's pretty painful. This is clumsy, like if you use Wireshark, you can click on packets one by one and read them. And I did that for years until I finally took a Wireshark class and learned how to do it right. There are much better ways to do it. So Here's the much better way to do it, which I learned from one of my visitors. You don't intercept anything. Let me go to my history, clear out the old stuff, right-click, clear history, yes. Okay, just buy one phone the way it is. Now, take a look here. Here's the request that bought that phone. You can tell because it sent a post up to my server at attack, and down here's this thing with the price. So what you do is right-click the request and send to repeater. These other tabs are where Burp really shines. The repeater lets you see a request, and you can now make as many modifications as you want. So I can look at this request, and I can now modify anything I like here, like change this price to 50, and then I can send it here with go, and I'll get the answer right there. Now the problem is the answer is unreadable. That's because it sent it in zipped form, which is appropriate for the browser, but it won't view it very well in Burp. So to fix that, I have to modify that on this end, and you can do that right here. You've accepted gzip encoding. That's the default that came from the browser. You can just delete that too. Now it will no longer accept zipped encoding. And the price is 50. Now I send it, and now I get readable plain text here, and now I can even render it and see it in the browser. Or I can see the HTML. Well, this is really fun, because now you can just modify stuff, try this, try this, try this, and you don't have to bother going back to your browser. So you generate one request and then just modify it. You can even type in a whole request here, but of course, the fun thing is to start with the request from the browser and then just modify whatever you're interested in. And that's the boss way to do it. That's what I highly recommend. And it even works when everything is HTTPS, as long as you've told it to trust your certificate. So that's good, clean fun. And that's how you buy a phone there. So here's a similar one. If you click here, it's going to set a cookie, which what might happen if you log in as a partner or something. Now I've got a discount of 10. So now if I buy a phone, I get it with a discount of 10. But I want a discount of 100, so I just do the same thing. I go to my proxy history. I find the post that did that. This is the post that had a discount of 10 in the cookie. So I just send that up to the repeater. Here's the request. I just find the discount. Your discount, it's in the cookie. There's the discount up here. So I can now make the discount 100. Okay, and I can make this a little wider there. You can see that I've changed the value of the cookie. Now, while I'm at it, I don't want it zipping anymore, so I'm going to get rid of this line. And now I can send that up to the server with go. And over here comes the answer, and I can render it. And as you see, I now bought a phone with a discount of 100. So that's perfectly fine. And if you want to turn in those screens for your homework, that's fine. If my grader gets confused, let me know. But I highly encourage you to do it this way. The exact way I did it in the textbook, in the instructions, is clumsy and old-fashioned. This is the cool way. Just use the repeater. So there are a bunch of variations of this. And let's go back to the lecture. But this is, I just made a demonstration for all these and put it in one of your homeworks. So here's the thing I put in the slides. Get rid of that accept encoding line if you want to do it this way in Burp. Otherwise, everything comes back zipped and it's annoying. Burp has an option, a box check that says unzip things that come back zipped, but it doesn't seem to work very well. So there might be some cool way to tell Burp to actually unzip the stuff, but I found it easier to just tell the server to quit zipping it. So, all right, you can also make this automatic. There's a box you can check here called match and replace. You can take the request header, accept encoding, and replace it with nothing automatically here. And then it'll automatically strip that request off of everything, which is kind of nice. So let me just do that so you've seen it. That is the way to make this automatic. So in Burp, on your proxy tab, in options, up here is the only place we've used so far, where you specify the IP address to listen on and such, but down here are more options. And you can, here are the match and replace options. Burp has a lot of stuff down here, and it's actually very nice. One thing I was amazed to find here is you have a SSL strip and pan-in-the-middle attack. If you want to stiff yourself with Wireshark, or you want, before I figured out how to put in the certificate, I turned on, there's a thing to downgrade HTTPS to HTTP. So Burp will connect to the server, it'll deliver it locally over HTTP, my browser will see it as HTTP. That's pretty awesome too. But trusting the certificate is fine too. So anyway, I'll just check this box, and now it will automatically change that request header to nothing every time. So now if I want to do the thing I just did, I will not have to do it automatically. So if I do this, let's go back here and do this one where you bought one. If I buy an iPhone here, and now I go to my history, and see the last purchase I made, which was here. I can view that in Burp. Here's my request, here's the response, and you can see down here, the response is no longer zipped because it's automatically turning off the zip request. And if you look at the original request and view it in raw form, here's the accept encoding, but it didn't really send that to the server. The server didn't get it. So that's pretty cool. All right, so I'll leave that turned on, and I think that'll make it easier to proceed here. So, a good clean trick. So there's cookies, like I say, you can change the cookies just like you can change the other parameters. They're just part of the request. You can modify that, alter the cookie value, and now you get a different discount. All right, you can change URL parameters. I mean, you can put parameters anywhere in the page. So this is hidden 3. Let me go to that one. So I go back to my page. Here's the third one, URL parameters. So buy an iPhone. I buy one phone. Oh, one phone. And submit. And it goes to the server. You bought one phone for $449. And if you look up in the URL, the price is just right up there. This is the place people put things sometimes. Obviously, this is the one where you don't even need Burp. I can just make the price 4. Press enter. Now I'm getting a phone for $4. So that's pretty awesome. All right, that makes life very easy when they do that. All right, and here's the referrer. If I submit, you're not allowed to buy because you have to come from apple.com. So let's fix that. If I go into Burp, and I go to the post that did that, that was a get to hidden 4. Here's the raw get, and I can copy this to the repeater, go to the repeater, and there's the request. It got rid of that accept zip, but it says it has the referrer right here. It's coming from samsclass.info. So all I have to do is get rid of that and make that apple.com, and then forward this one. Now, you bought an iPhone from apple.com. So this is why, you shouldn't trust the referrer. You can also modify it. All these are the same basic trick, but there's an endless series of developers that won't understand this, making vulnerable pages. Here's the length limit. This is protected by JavaScript. If I highlight this and inspect it, I can do here, it'll do that, I think, in Firefox. Right click, inspect element. I should be able to see my source code. Okay, here's my form. Now in the form, I put a max length equal 1. The form will only let you type in 1 character. That's my protection against people buying too much. So I can buy 3 phones, but I cannot buy 10 phones. If I type in 1 and press the 0, nothing happens because I only put in 1 character. Of course, we know how to fix that. It's the same thing for all this stuff. You go into Burp, go to the proxy history, and you find that request, which is this one, that sent quantity of 1. Copy it to the repeater, find it here, change the quantity to 10. Then forward it, and over here's the answer. Congratulations, you bought 10 phones. So that's the game. All right. All right, then you can have hidden parameters. You could put in the URL. Now, one thing you can do, to trick people into buying things, you can put a page that puts an HTTP request in an image source tag. So it will not appear as an image on the page, and when they just view the page, it will go make this request. This is one of the many examples of cross-site request forgery, cross-site scripting, and this is why, like I say, when he was talking about running cryptocurrency mining from a website, I said, well, if you view the page, you've already consented to let them do a lot of things to you. They could put links like this on their page. So anyway, all right, there's a lot of tricks. Iframes do it, form actions do it. There's a lot of ways to put parameters, send them up to the server in many ways, and all these are unsafe. All these put parameters in the URL, they all could be modified by proxy. So the developer can't really trust any of those things to be there, so you shouldn't be sending things like a price that matter there. All you should be sending to the server is something like a product number, and then you look up the price on the server. Now you might want to have the price on the client so you can display it to the user and calculate their total in the shopping cart, but the price you actually charge them should come from the server, not from the client. There's the referrer header. Like I say, often developers trust it, but they shouldn't. So we did that one already. You can buy an iPhone from Apple. So one technique people use is they try to scramble the data so the end user can't easily modify it. And if this is done correctly, it could be reasonably secure. So you put in this value junk, just this long hexadecimal stuff, and if it's something foolish like just base 64 or hex encoding, then the viewer can still modify it. But if it's actually scrambled with something like a private key encryption or keyed hash or something, then it is difficult for the user to modify. The problem is the user may be able to send plain text up to some part of your application and get scrambled stuff back. So they might be able to pump scrambled stuff out of your server. I might be able to go to something like upload my profile picture, and when I put up my profile pic that's named Sam, the response might have a scrambled version of the name or something like that. So I can go there and put up a profile picture like $10 with the name, get the scrambled version, and now use that to change the price if you didn't really make it unique every time. That's one trick. Another thing you can do is just replay opaque text. I can just go to some other part of the app that has text that's interesting, like somebody else's request, and just replay that without decrypting it, and now they'll think I'm that other person or something like that. You know, we'll do quite a few tricks like that as we go ahead. Encryption doesn't prevent all attacks. It just means you have to take the scrambled stuff you have, like dominoes, and rearrange it to build attacks. It lowers your ability to make any attack, but there are some attacks you can still do, even if stuff is encrypted and you can't decrypt it. All right, so ASP.NET does this. It has a thing called ViewState, which is intended for this purpose. This is why such a common thing, that the developers send something down to the client, and then when it comes back, they want to trust it. That the servers have these mechanisms to attempt to do this very messed up thing. It's like Facebook. People post things on Facebook and they don't want the whole world seeing them, which is kind of insane, but that's the reality. So Facebook has these attempts to protect your stuff from the unauthorized people. And so anyway, that's the game. So you can put things in ViewState in your code. And that will, instead of putting it in just in a cookie or a parameter, it will put it in this structure called ViewState, which is sent to the user as this long base 64 encoded thing. And that is the idea, that data can be sent to the user and recognized when it comes back, but the user will be unable to unscramble it and modify it, so you can trust it to some extent. The user can, of course, delete it, but if you do get it, you can do an internal verification check and know that it hasn't been altered to some degree of security. So it's base 64 encoded data. Burp has a ViewState parser. There are different versions of ViewState. Some of them do not use MAC protection with a keyed hash at the end, so you can modify them. Others have a keyed hash. So even though you can decode it and modify it, if you do send it to the server will reject it because you can't make the keyed hash work. But anyway, it depends on whether they turned on all the security features of ViewState or if they're using the older, less secure version. The Burp Suite has a ViewState decoder, so here it is. It will unpack stuff. It tells you the MAC is not enabled, therefore the ViewState can be opened, modified, and repacked. So it's not doing any good in this case. Yeah.
Are things like ViewState and Burp, is that like a module that you need to enable? Or
I think this one's included by default, but I think the Java ones are not.
Maybe I just
But maybe you do have to add it. There's a Java one coming up that you have to download as third party, and some of them you have to pay for. So I'm not sure if you have this one for in the free version or not. I haven't played with it. I'm low on Microsoft servers. I need to get like a good source of them. If I can have good Microsoft cloud servers, there's a couple projects I need where I really need a Microsoft server. It's about time to bite the bullet. And I get that up there. All my stuff is Linux heavy. Anyway, so HTML forms are here. Like I say, this is the one you saw where it limits you to only one character in the HTML, but you can easily overcome that by modifying it after the browser is done with it as it passes through Burp. If you refresh a page, this is another thing that happens. You refresh a page and you won't actually get the new page. This happens pretty often because the server will check the version number or the date and tell you the page is not modified. And that is okay if you were a viewer viewing the page, but if we're doing some kind of attack, I really do want to reload the page in order to capture the traffic. And so you have to do shift refresh to force a real refresh in your browser. Because the server sent an if modified since request, so it doesn't bother reloading pages that haven't been modified. But if you want to force a request, you do shift refresh. You could also use burp with that modification section, and you can take away the if modified since and if none modified headers from requests, so it will always make a clean request, which is of course not appropriate for normal browsing, but it is appropriate for us where we're deliberately doing 20 similar requests to a page that is not changing because we're doing some kind of attack. All right, then there's script-based validation. You see this on almost every page. They have this validate form, and this will go check things, quantity too long, password contains funny characters, zip code too long, and all that jazz. Well, people use this all the time, and there's nothing wrong with it if you understand what it does. What this does is it helps your user fill out the form. So if they make a typo, they can fix it without having to send something to the server. But it doesn't mean you can believe that any of that is true when it gets to the server. So you can just replace the value after the script runs. You could also disable JavaScript. You could also save the source code locally, modify the script, and run the local modified version. There's plenty of ways to do it, but here's how you do it in Burp, of course. You run the script. The script limits this number not to go above 5, but I can, of course, just change it after I get in Burp. So let me do this one, and then I'll show you the blanket statement, which makes it easy to cheat on the homework. If you want to call it cheating, you can do the homework very easily. Here I try to put in 7. If I try to buy 7 and submit it, it will say quantity too large. Pop-up box, it refuses to do the submit out of my browser. So to defeat that, I put in a legal quantity, do the submit, now it's sent it to the server, and now I can use Burp. Now that I have an example of the correct request, I can go here and find it. That looks like it. Post to hidden 6. Send that to the repeater. Exactly the same process. I go to the repeater. Repeater shows a quantity. I can now make this 122 and go. And now I get, you bought 122 phones. So that's the point. The defeating process is the same for almost all these because you can just ignore the local scripting and all the other browser-based defenses. So if you do use JavaScript, you submit data that you just use a proxy to modify it, and this is what you will do to find out if validation is also performed on the server. And this is one of those things that security people, why developers hate security people, you have to do everything twice. You have to do it on the client and on the server. You do it on the client for the convenience of the user, and you do it on the server to make sure the data is good coming in. Otherwise, these attacks become possible.
Would you recommend also do it on the database too?
Every time, yeah, and that's what's in the book. Your server cluster, your whole server is modular. You have a database server, a domain controller, a web server, a lot of servers. Every server should filter all inputs from everywhere.
No, that's not what I'm saying. Like so you can filter your client, your data on the client.
Yeah.
You can filter it also on the server.
Yeah.
But then I'm asking, do you also, because you can add it on the database as well.
Yes.
Would you recommend that as well? So
Yes.
Three layered.
Yeah, and that's what I'm saying. You should, because people would be tempted to say no, because the database server doesn't get requests straight from the client. It gets requests only from a web server.
Sure.
But you should filter it anyway, because everything can be untrusted. And we were talking about this before. You can't trust anything. That's what's recommended. Every time you have a boundary and data is coming in, you should not trust it. You should validate it, because there will be a way to trick the previous box into forwarding. So that's what SQL injection is. I send something to the HTML form, which looks okay to it, and it passes it on the server, which now it's an attack. You can't expect the HTML server to block SQL injection because it doesn't even know what SQL is. It's the database server that has to block it. It's so yeah, every module should filter everything coming in and everything going out to try to block attacks. That's the only way to be safe. And of course, nothing's ever perfect. This is why security is generally seen as a drain on your costs and everything else. It means everybody has to think about stuff they'd rather not think about. Your database engineer has to think about evil things coming in when they would rather say, oh, I just trust that other server because it's part of my company. All right. So that's what I've said here. The reason why you do client-side validation is to make your thing respond more and help the user fill out the form, but it's not to make you safer. client-side validation does not make you safer at all. Then there's disabled elements. You might do this. You can have a 449 sitting here, and it cannot be changed. It's grayed out. And this one will not even be sent to the server. So let's take a look at that one. This is another trick people use. And I'm not sure there's any legitimate reason for this one at all. But here's a disabled field. So I can put in a quantity of 12, and the price is there, but I can't type in there. The cursor won't even go into that field. It's just sitting there. So that's a disabled HTML field. So if I submit this to the server, and then look at what actually happened in Burp on my proxy history, it did this. Okay, it sent a thing up to the server. It sent up the quantity, but it did not send the price to the server at all. It's not included. Now that might be fine, but I can add a parameter that was not here, and that's what I have to do. So I go to repeater. Here's my request. Here's my parameters. You can just add another parameter. Price. 30. And the server might fall for it. So I put that in. Now I go. And if the server falls for it, it will now let me control the price, even though I had a disabled field. The fact that it was disabled kind of suggests that some other part of the page or some earlier version of the page actually sent the price. So that means the server might still be listening for that price. And this is another thing that was in the textbook last time. They say take your request and just add another parameter that says like isAdmin equals true or debug equals 1 or something like that. And servers will often respond to that. And this just came out last week. I think it's Netgear routers had this flaw. All you have to do is add admin equals 1 and you're the administrator to the request. So all these things they sound too stupid to be true, but they're all based on real experience. All these things really happen. You can add a parameter there. All right. And like I say, you can also do, this is the gold standard. You can go to response modification and just take all the defenses out of every web page automatically. This is the way to really do it. The homework where you do this, you can go through those steps or you can just skip right to the end this way. You go to your proxy options and you go here and you just remove the hidden fields, enable disabled fields, remove input length limits, remove JavaScript form call validation. There. Now, when you load a page, it's going to have everything removed. So now you can do the whole project without using Burp at all. You go back to here. Now this page is okay. You need to refresh the page. Now if you try refreshing it, you don't really get it because it notices it has not been updated. This is one of those cases where you got to do shift refresh to really load the page, and now Burp will modify it. So suddenly the hidden field is just sitting right there, and you can modify it. And the hidden field is just right there. You can modify it. The length limit is just gone. Because what Burp did is when the HTML came back, it noticed these things and just removed them. So the page that went to my browser didn't have it. And the script date validation just won't, maximum is 5, but I can just put in any number now because it just found that and removed it. And the disabled field is now enabled again. So this is like magic. It does not fix everything, but most of the attacks are just now automatic. That's pretty cool. All right. Burp is a real time saver for this stuff. All right, and that's the game of so. I got a few cahoots about that stuff. So, why do web apps send data to the user and then expect the user to send it back? That's it. It helps you coordinate administrative problems if you have many servers. All right, which item is easy for the end user to modify without using Burp? Okay, URL parameter is the one that you can easily see and modify. So what do you have to do to make a response render correctly in Burp Repeater? Okay, gotta get rid of that accept encoding so it does not zip stuff. And if you want to completely reload a page, what do you have to do? Okay, shift refresh, that's good. All right, so there are browser extensions, unfortunately. The things are pretty much a security disaster, and in fact, they're less and less important these days. But until a few years ago, when everything started moving to HTML5, everybody had Flash and Java and Silverlight and all this garbage in their browser, and therefore they had all these other kinds of data coming in. And the point of these things is they all send compiled code to your browser, so complicated things can run faster, like Flash games and such. But it's not generally encrypted or protected, so you can modify this stuff. So you could tamper with the contents of these Flash videos and such. You could find things in here to give you access to server-side things. You could cheat at games, cheat at gambling, and all that jazz by messing with it. So all these things are compiled to bytecode, Java, Flash, and Silverlight. They are not compiled all the way to machine language because that's the way it works. In order to be independent of your operating system and your hardware, they run a sort of virtual machine sandbox, and then they take the bytecode and run it there. So it runs much faster than high-level languages like JavaScript, but not as fast as compiled native apps. That's the idea. And this was while all advanced features use these things because browsers, until a few years ago, were so slow at running JavaScript that you could only do very simple things in the browser itself, and anything more had to be in one of these plugins. So Java is the one that's still in use a lot. The others are pretty much fading out. And Java on the client runs in a Java virtual machine. It is extremely insecure. It's been very dangerous. They've greatly improved their security in the last few years after years of it just being horrible. And the number of people actually using it on normal clients is going down because you really don't need it. Where people need it is at work, at their company. Companies use Java things all the time, and then people have to have a client on their machine to use those Java stuff. Flash was the standard on the web for many years until Apple killed it by refusing to put Flash on the iPhone and the iPad. And that was a large market of customers, so nobody was willing to put their website in Flash anymore because they're not willing to write off all the iPhone users. And Steve Jobs absolutely refused to budge and put Flash on the iPhone. He said, this is a lousy technology and I'm not polluting my beautiful phone with it, which he's certainly right about the security side of it, although I think he was thinking about the battery drain and performance side of it, which is probably also true, although I don't know that, but the security was awful. So in principle, the stuff is sandboxed. It's got this language. It's written in ActionScript. And you can take classes and learn to program Flash, but I certainly wouldn't bother anymore because very few people use Flash anymore. Up to maybe 3 years ago, you could just assume that every browser had Flash on it, but now you can't really assume that anymore. A lot of people don't have it and don't care, and so everybody used to use Flash is now moving to HTML5 instead. Silverlight was always an abortion. It was Microsoft's attempt to subvert Flash. Microsoft does this over and over and over. There's a technology where somebody already owns the whole market and they march in with something that is not good enough and pound on it and try to convince everyone to use it, and then they just give up and crawl away like a beaten dog. They did this with VB script to compete with JavaScript. They did this with the Windows Phone to compete with the iPhone and Android. They did this with their imitation Flash called Silverlight. They make this thing that is not really any better. They try to get developers to use it. Nobody cares. Everyone just ignores them and uses the standard until they just give up and go home. And now even Microsoft doesn't support Silverlight anymore. So, you know, it came and went. So if you want to mess with the extensions, you can, of course, grab the data in the proxy like Burp and modify it on the way through. That's one way to do it. If you try to do that, you'll find it's obfuscated or encrypted, typically like those ASP.NET data structures. But you can often decompile the bytecode and read the source. You can run it in the debugger and modify it. You can modify the programming. This is somewhat time-consuming, but pretty easy. It's pretty easy for Android apps, so that's the one place where I've done it most. This is the general field of reverse engineering, where you take something apart and look at it to figure out how it works. Even looking at the source code of a web page and figuring out how it works, which is what we're doing here, is a type of reverse engineering. Instead of just viewing the finished product and using the buttons the developer put there, you figure out how it works and figure out how to trick it into doing unexpected things. So All right, if you grab the traffic coming out of the Flash apps, you can often defeat server-side control. If the data has been serialized, like we converted into some base64 encoded stuff, it might be more difficult. You'd have to unpack it, modify it, and pack it again. But you will often find that you can cheat at games and gambling and change things and stuff like that. Here's Java serialization, one of the forms. They make this thing called Java serialized objects. The content type header tells you there is a Burp plugin called deesser you can get, which is intended to unpack serialized Java. And this is how it looks. You turn on deesser, and now it unpacks it, so what you see in Burp is this horrible stuff, just binary junk, a lot of it unprintable. Deesser unpacks it and shows you a form. Now you can modify the form, it will reconstruct it, reserialize it, and send it to the server. Just like that ASP.NET ViewState data, if they do not have the defenses turned on, it's not really protecting you. It's just an irritation. It's not a real block stopping you from modifying it. Flash has serialization also. And Burp can handle that natively, which is kind of a mistake of consequence. Burp was developed back in the days when Flash was super popular. So at that time, it made sense. Now it probably wouldn't make any sense to bother including a native Flash deserializer. And so Burp Professional can do it. It can automatically unpack the Flash and then show you the contents, let you modify it, and then repack it and send it to the server so the server never knows you tampered with it. And Silverlight is also serializes its stuff, and there is a way to deserialize it, which is very complicated. Talk to your book. You actually have to use 2 copies of Burp and plugins and all this complicated stuff, and it doesn't matter because nobody uses Silverlight anymore. I think there is one exception. I actually have it on one of my computers at home. There's something. I think, until recently, the City College online classes, I think, used Silverlight, which is what tends to happen. I mean, they bribe like some small market, like a government market, to use it. Like, I remember I had a student, I taught Windows tech support for years. I taught Windows XP, then I taught Windows Vista, and then Windows 7 came out. I immediately moved to Windows 7. I had a student say, wait a minute, I took this class to get Vista certification. And I said, why in the world does anybody get Vista certification? He said, the US Army standardized on Vista. So there was an exchange of money somewhere, and the US Army standardized on Vista, which no one else even touched at all, like Windows 8. Vista was one of those Microsoft abortions where you just turn the picture to the wall and pretend it never happened. Everybody went from Windows XP to Windows 7 to Windows 10. Nobody used Windows 8 or Vista unless they were masochists.
Or ME.
Yeah, or ME. Every other version is just appalling, and everybody just waits for the one after it, which is nice.
It's going to die on 2020. It's like support will be dead for Windows 7 on 2020.
Oh yeah, that's when, and then we moved to Windows 10, which is not horrible, but nobody had to put up with Windows 8 unless they're a masochist. Anyway, so if you want to intercept this stuff, some of these requests bypass the proxy. They're going out some other thing. I've seen this on Android phones. So you might have a problem where some of the traffic does not pass through the proxy. The proxy setting in the browser does not really redirect all traffic. So you can modify the hosts file to change the IP address to 127.0.0.1. And then it will send all the requests there, and then you use invisible proxying. That's one option. Another thing that might happen is your client component might have SSL certificate verification that uses the operating system instead of the browser. Now, the exception you put in Firefox will not be recognized by the component. So in that case, you would have to change your proxy to use a master CA certificate instead of making a separate false certificate for each website, which is the default. It's just an option in Burp. Then export that and then put it in your operating system's trusted certificate store. And now any connection made with the operating system API will accept the fake certificate. So it's a slightly more complicated process, but it will redirect all traffic through HTTPS. At least it will stop complaining about these certificates. Of course, there's another way to do it, which is what CERT did to test all the Android apps in existence in about 2013. They took a real physical router in the middle and put a certificate generator on that, so all the traffic passing through the physical router was intercepted. That's the way to really do it. And I've done that when I teach the mobile device hacking class. Students can test their devices. I turn on my computer to be a man in the middle, offer a wireless network, and anybody that joins my network is going through this box. There's no other choice. So you know that anybody on that network, I can see their traffic going through. That's when you really get tired of messing around, you just go to layer 1 and put yourself in the middle this way. Then you know you're in the middle. All right, if the client is using non-HTTP protocols, then it's not going to pay attention to the browser's proxy settings. You can sniff it with Wireshark still. If it goes out the network card, Wireshark can see it, so you can see the traffic. There are function hooking tools, like Echo Mirage is something I've never used, attempting to hook this traffic. That's one option if you can find such a tool. Like I say, these are just other kinds of more complicated proxies to try to catch other kinds of traffic. So make sure that your proxy is getting everything correctly. You can use a sniffer like Wireshark to see what packets are being sent, and then you can see if it's really all getting in your proxy or not. I've done this pretty often when testing Android apps. There are quite a few Android apps that send some data past the proxy. You may need an unpacker. You may have responses from the server that trigger the logic that you have to mess with, and so on. You can now watch and see what happens. Interesting questions, like when you roll the dice in a gambling app, does that dice rolling happen on the client or the server? The developer may well have not known or cared, but you care, of course, because if it's happening on the client, then you control it. All right, so I got a few cahoots about that. So which ones are compiled to bytecode? Okay. All right, so HTML is the only thing that's actually not handled by an extension on that list. So which technology was killed by Apple?
Oh!
These things are all pretty horrible ideas. They're all on the way out.
Killed by Apple.
Apple got rid of this one, which was that's Flash. Apple killed Flash by not supporting it and using their market pressure to make it undesirable. And which one did Microsoft promote, but it failed anyway? Which happens a lot. Yep, that's Silverlight. Microsoft is like, there's a lot of movie recording studios like this. They have like 4 flops and a hit, and then 4 flops and a hit. That's Microsoft. They have all these things that die, and then a big hit, which pays for all the rest. So they make record profits. So, all right. So how do you force all the components to let Burp man in the middle your HTTPS? Which is something that they will all try to resist doing, of course. Okay, that's it. You need a master certificate in the OS Trusted Store, and then every app on that device should trust it. There is an exception, which is true only in theory. There's this thing called HTTPS pinning, where your app actually knows what the right certificate should be. It has some independent information about that and will not accept any forgeries. That is a theoretical construct, but even the people that developed the system have pretty much stopped using it, like PGP. It turns out to be so difficult to maintain that people have pretty much given up. And that would be a case where even this won't work. But that turns out to make so much trouble, it never became popular. By the way, if someone like you might wonder if you're passing or something, the scores are up. I don't have them up for all my classes yet, but I do have them for this class. Right there are the scores. So I can ask a question like, is anybody doing the projects? And you see a bunch of people are doing the projects. So they aren't all attending the class in real time, but I don't care, as long as you learn it somehow. They're reading the book or watching the videos or somehow. So here's your last 4 of your student ID, and there's all the scores, and this will be up there. It's updated frequently. So everything you do should end up here, and you should check this now and then. Then there's some strange people that bring in extra credit elsewhere, but except for most people earn credit the other way. But like I say, if you do a CTF or something, if you do a lot of easy CTF, you could have like 80 points over here too. There's other ways to make credit besides doing my official projects. All right, so a little bit more to say about this stuff. So if you have browser extensions, you can actually look at the source code and decompile them and analyze the extension, like the Flash file or something, and figure out how that works. Some people obfuscate their code, not particularly to stop security attackers, but to stop people from just copying their intellectual property. You may know the most common way people make web pages is they just get view source on other web pages and just cut and paste other people's pages to make pages. This is very common. It is very annoying to developers, of course, who worked hard to make that page and then every page looks the same. And so they often try to obfuscate the code to make it more difficult for people to copy their stuff. So if you want to do this, you can download the bytecode, you can get Java applets. At one time you could just put it in the URL. I used to get Flash games this way. I would play Flash games and they were too slow, so I would just download them and put them locally. They didn't run fast. I would just go in the source code and find the URL to the Flash game, put it in directly, and download it. That works, but people make it a little more difficult with modern techniques. If you can't easily find it, you can look in the proxy history. Some proxies filter it. Browsers sometimes cache the bytecode, so it's often in your browser. Anyway, you can get it. Here's another tip. You identify the request for the bytecode in your Burp history, and the server response has the whole bytecode. You can save it directly to a file from inside Burp. You can also save data directly to a file from inside Wireshark. Now that's a good thing. So this is handy. It helped me solve a CTF today. There was a page that protected you from seeing the source code, so I captured it in Wireshark and saved it from there. It was more complicated than it could have been because there were many files involved in the page. You have to save them all, but it wasn't too hard to do. So the bytecode comes in its form. Java applets are jar files containing class files. Silverlights are zap files. Both of these are actually just zip files. I don't know why they bother using a new extension. They're just zip archives. You can just unzip them with any unzipper, like WinZip or 7-zip, and then you just get a bunch of files. That's why there's a Java-based assembly simulator called Jasmine that my students were using, but it was written by students in Germany, and they put a picture of a partially undressed teenage woman on the cover. And Americans are horrified at this pornography. So I wanted people to use it, so I said, how hard would it be for me to change that picture? Boy, it was easy. All I did was unzip it, find the image, put in another image, zip it back up, and it runs. There's now a version I put on my webpage that has a flower instead of a picture picture. It's very easy to modify these things. So there are decompilers. JET is a Java decompiler. There are Flash decompilers and Silverlight decompilers, as if anybody cares. But Java is important because even if you're not using the Java plugin in your browser, everything in Android runs on Java. And that's where I do it all the time. And if you take the Android hacking class or mobile device hacking class, which I think is not next semester, but the semester after, we'll be doing plenty of this. So this is how it all started for me. I went to the Bank of America, got the Bank of America app. Every app you get from Android is an APK file. The APK file is just a zip file with all the source code in it, just right there. So you can just download it. You can use this free product called APK Tool. That will unzip it. And then you can just get plain text files. And you'll see they try to obfuscate it. This is something people say to do. In order to stop people from finding secrets, you should obfuscate code. There's this thing that Google wrote called ProGuard, included in Android Studio, which is supposed to protect your app, and this is what it does. It changed these folder names to A, B, and C, but it doesn't change them all. I've still got deals and deposits. I've still got business credit card details activity. So it doesn't change them all. It just changes some of the names. So this is like a security guard that locks half the doors and goes home. It accomplishes nothing. I've never had this thing slow me down a bit hacking Android apps. I don't know why people waste their time using it, but it's free. This is what Java looks like. You have a public, you have a comment here, you have a name of parameters, put username, password. So if you wanted to see where the password was handled in Java source code, you would just find it this easy. And this is not given to you with the app. What's given to you is Smali code, but this is what Smali looks like. Username, password, parameter, string. It's almost as readable as the Java source code. This is and developers typically do not understand this. If you compile x86 code for a Windows machine, you get this binary stuff that is not easy to read and manipulate. We're doing it in 127, but it's not easy. If you compile code and put it on an Apple, it's compiled, and that code is not easy to read. If you put it on Android, it is easy to read and modify. You can just read the plain text, you can just see things. So if I want to modify the Bank of America app to steal the password, this is all I have to do. I go into the Bank of America app, I change the number of local variables in the routine up by 2, so I have a couple. Then down here, I put in this command, which puts the string in the log. This is the credit card number, this is the CVV. Now it puts them in the log. The log is available to every app on the phone. This is the syslog. I was wanting to send it right up to Pastebin, but making a TCP socket would take too many lines of Smali. I couldn't figure out how to do that, so I settled for just putting it in the log. Now you just pack it and sign it again. Another insane thing about Android is code has to be signed, but it doesn't have to be signed by a trusted person. You can just sign it with a self-signed certificate, and your phone will just accept it and let it run. I don't know why you bother signing it if you're not going to then verify the certificate. And now I made a modified version of the Bank of Apps thing, which does connect to their server and runs just fine and steals the credit card numbers and puts them in the log. And almost every Android app has this vulnerability. Their binary is not protected, and anybody can just modify it and make fake copies of the app. And the companies don't care. If you tell them, they will not do anything about it. I imagine this is because for a long time they would not do anything about the fact that their websites were all insecure. Until about 5 years ago, all banks had HTTP websites, and when you click the login button, it uses HTTPS. And that means anybody can make a perfectly good-looking imitation and phish you, but that's not the bank's problem because they're not committing that crime. It's someone else imitating them, and the fact that they made themselves easy to imitate was not their responsibility until the laws were changed to make it their responsibility, and now suddenly they all use HTTPS. So we need a law change for this. Technically, it's not the bank's problem that I can copy their app, make an evil version, and distribute it, but it's not so common in America, but in other countries, a lot of people get all their apps on unofficial stores, like China, because the Great Firewall of China blocks the official app store, so you have to get it from unofficial sources. And by the way, the official store is all full of fake apps. The Microsoft phone app store was completely full of fake apps. When they brought it out, in order to make the app count go up to advertise it, they didn't filter it at all, so there were like 300 fake Flash PDF viewers, and Flash PDF viewers, and all fake, no real ones. I remember I went to Android app, and I found the Spirit Airlines app, and I loaded it up, and it sent the password up in plain text, so I notified Spirit, and I said, hey, your app sends the password up in plain text, and they said, app? You don't have an app. I said, well, somebody put up the Spirit Android app. And this happened when about 5 or 6 years ago when Android was new. The first banking app was not from that bank. Some enterprising fisher made a fake app for a bank, put it in there. They don't verify the owner or anything. So people were using it to log into the bank. This was in the official store. So, this stuff happens. Anyway, that's an example of the reverse engineering these products. That's Java, which is the most important version of it these days. Anyway, so you can work on the client-side shortcode. You'll find in the source code input validation, hidden functionality, references to server-side functionality in source code. You can learn a lot in there. It's kind of a drag to hunt through it, but you get used to it. I got quite practiced at this. I reverse engineered hundreds of Android apps until it became sort of like a fun game. And there are some things they'll fix. The ones that actually break HTTPS, they'll fix that mostly, although it took I think Options House 2 years to fix it. Financial apps, where I think it should be most important, they seem to have the least interest in it. I think probably because they deal with risky investments, they laugh at all their risks. But anyway, so you can recompile it with Java C, LASM, or Visual Studio, and just recompile it, zip it back up, put the modified component back in the browser, and you can run it there. And that's a game. You can modify all these things and see how they go. You can also use proxy like Burp to modify the traffic coming in and out. And Burp has some tools to make it easier for you to copy large amounts of data back and forth. And here's an example of this. You have this junk you can't read, you can copy it into a file, and you can process it in a file to change it and paste it back in from the file. So you can write a script like in Python or something over here to unzip this stuff and change it and zip it back up. Making it easy to extend Burp with custom tools as needed, and forget other tools to go along with it. So you can modify the app to run standalone, run it outside the browser, and then you can edit the responses, add JavaScript to the responses so the page can now be manipulated. Bytecode is sometimes obfuscated, so if that happens, you'll see FD float enabled and all this jazz here. People can choose to obfuscate variable names and such. You saw that in that Android app. It's typically very weak. There are some actual pro products for Android that really obfuscate the code to where you really can't read it anymore. It costs like $2,000. ArcSand does that. But almost nobody bothers. Even the expensive banks don't bother using it. That's one thing I told them in my vulnerability reports. You should just pay $2,000 and use this tool, and then nobody could read your source code or modify it, but they just don't do it. I guess what it means, of course, is they are not really losing any money from this attack that they know of. So it's just not important to them. Anyway, that's what obfuscation does. Replace the names with meaningless names, replace the folder names, method names, variable names. And another thing you can do is use reserved words, like new and int for local variable names. This will work in some machines. Well, I remember back in the old days of using Windows and MS-DOS, there are certain names you cannot use for a file, like con, because it's a reserved word. And so the same thing apply here. You can break some rules, and it'll work inside the sandbox, but it won't work when the tool's outside trying to reverse engineer the app. These things are called anti-forensic techniques. There's quite a few of them. There are files you can put on your hard drive that will crash forensic tools. There's a whole bunch of them you can get from DEFT. When I taught the forensics class, we went through that. There are some hacking groups in Germany that specialize in writing these things. You can write files which will cause the tool to crash. One of the simplest ones is a zip bomb. This is a fun file, and some people say you should do this to stop people from stealing your data. Zip bombs is a carefully crafted file, which is small, like maybe 10 or 20 kilobytes, but is crafted so that if you unzip it, it turns into like 1,000 terabytes. What? So it's easy enough to do. What you do is you just make it bit by bit, make the zip file. Make it have millions of folders all full of millions of files. And so the point is, it'll sit on your drive harmlessly, but anybody that tries to steal your data or make a forensic image and tries to unzip it, it'll crash. And there are more nasty ones that will crash the operating system of forensic tools and such. And there's this is the whole world of offensive security. There's a guy that gives quite a few talks at the conferences suggesting that you put these booby traps on your server to punish the bad guys that steal it. Another thing you could do is you could put an executable in your files, which when the bad guy runs it, will send his information back to you so you know who stole your stuff and you can hand it to the cops. That's how the cops caught pedophiles, behind Tor. So there are these activities. If you're going to do any of them, check with your lawyer, because at some level, putting booby traps out there might be illegal, but in practice, I think putting it in my files that somebody steals, I would think it's hard to hold you accountable for that. But anyway, that's the game. So you can remove meta information from your files, like source files and line numbers and such, and add extra code to confuse the reverse engineer. In the malware analysis class, we talk about this. You can even compile your compiled code so that it cannot be decompiled. There are a couple of good ways. One awesome way, which came out recently, is to compile everything into move commands. Move is NP complete. You can do everything with move, and no, you can't read it or understand it. And there are also ways to just add extra unnecessary bytes in the middle of instructions, which will foul up IDA-Pro and other decompilers. There's a bunch of ways to do it. Not very many people do it, but virus writers do that stuff. You can modify the path of execution so it's not obvious. You can jump around to code in a non-obvious way. You can add illegal bits of code that will make everything crash that in fact you jump over and don't use, but it will foul up the reverse engineering tools. All these things can be done, but they are very rarely done by legitimate code. All right. Even if you obfuscate things, some things remain readable. And there are many integrated development environments that can reconstruct code. When I do CTFs and malware research and otherwise look at executables, there are tools that will reconstruct source code. It's not perfect, but they're pretty good. Hopper will do that. Hopper will build C code for you out of the compiled stuff to make it easier to read and analyze. And there are putting things through an obfuscator twice might undo the obfuscation. That's fairly common that these things undo themselves. So here's a portion of the code that defines a hidden field called obpad, which has this long value. And I think that value actually has no purpose, but it might be used to like encrypt the rest of it or something. Then you have a JavaScript validator, that's right, which is going to check it, and it will somehow use that long obpad value to validate the other, like encrypt it with that used as a key or something, so that if you change anything, you're not going to be able to reconstruct it. I've met a lot of Android apps that try this, but since I can see the source code, it doesn't do them any good because I can totally see the encryption routine and their private key right in there. So many Android apps are this way. They are not aware of the fact that they can't hide anything. If you really want to do this, the right way to do it is public key encryption. You encrypt whatever stuff is on the phone with a public key to keep the private key on the server. And there is no way anybody can fake it from the other end. This technology has been around since 1970, but the developers haven't got the memo yet. So this thing will check the quantity, and it's by knowing the algorithm and the meaning of that hidden variable is the only way they can. If you modify something and send it up to the server, the obpad thing will obfuscate it. So it's not easy to see, and the server would have an opportunity to detect that it's been modified if it has internal integrity checks on that thing. So that's the game, and you can decompile with JAD and recompile. We're not going to do this in this class, but I do it in the mobile device class with Android apps, which I think is the most interesting application of this stuff. All right. You can write your own code to do this. You can modify the applet and so on. And we'll do a little bit of this in the Android class, but I'm not planning to do it here. There's a Java debugger called Java Snoop you could use that might make this process easier if you really want to mess with Java applets. And you do attach it to a running process, and then you can pause code, modify it as it runs, and hook classes and see what they do. Useful for reverse engineering Java apps. We use simpler techniques in the current Android device class, but if people want to figure this out, it would be fine. I think that's the main place where Java apps are used these days. And in this thing, you can easily edit credentials and such. There's also a canary mode, which is a cute idea where it feeds a special data and then hunts for that data to watch where it goes through the app. That way you don't really have to read the code, you just watch to see where this special value goes and you get some idea. That's how I actually just finished the CTF. The CTF with all this fouled up source code. I tried to reverse engineer the source code and I got it almost right, to where I got like about half the letters right in the key. So I just searched through it for everything that looked like encrypted data and tried every combination of everything until I happened to find the right parameters, because there weren't that many.
So you're done?
No, but I finished one high value problem. Oh, there's more. Anyway, some things you can't do in the sandbox. And for these, you have native code components. ActiveX is another one of these appalling technologies that runs direct compiled code from inside the browser. This was Microsoft's attempt to make powerful things. Windows Update runs in ActiveX on Internet Explorer. This turned out to be a security nightmare. There was generations of attacks because you're downloading code which then runs compiled locally with no defenses. And again, it's pretty much extinct. ActiveX, Silverlight, Flash, all these things were sort of terrible ideas that have come and gone, like the dodo bird, pretty much. If you do get native code, compiled apps, then you use binary compilers like IDPro to disassemble and Ollie debug to debug. And we do that in the malware analysis and exploit development class. You can learn how to do that here in simple cases. And the pros go up to the sky. One of my most advanced students became a real expert at IDPro. He got the pro version and he found like a new iPhone jailbreak and several other major iPhone security. He had the first new jailbreak in 7 years. He was bloody awesome. But I think he's being sent back to his home country for failure to keep a visa. Anyway, but he was pretty awesome, and he could actually stare at IDPro and understand everything. IDPro is worth like a whole degree in itself. It's very complicated, but people that get good at it are in high demand. Only a few people can really read that and understand it, and they're in great demand. So don't send critical data like prices from the client. If you do receive something from a client, remember it could have been modified. Even if you did something like put it in a data structure like an ASP data structure, that doesn't really mean the client can't modify it. And even if you think the client won't be smart enough to untangle all this, they don't have to. Just some guy in Russia writes a virus that does that, and they get infected with that virus. And over there's in failed states, where there are no real jobs, so the professional programmers go to college, get degrees, and spend all the whole working days for months writing sophisticated viruses. They really will reverse engineer all this and make a virus that defeats it all. So that's the game. If you got to send
it on the black market.
Yeah, they use it to make money. So you can't assume that just because it's difficult, it won't happen. If you got to send important data, you can sign or encrypt it. There are perfectly good cryptographic ways to label data so you can totally tell if it's modified. The techniques exist, but you do have to actually read a crypto book and get your crypto right. The Android developers make fools of themselves by pretending to do this and using the wrong cryptographic primitives, so it does not accomplish the goal. But if you wanted to sign something and then know whether it's been modified, that can really be done, as long as you use the tools properly. So anything on the client is vulnerable. The only reason you put anything on the client is for performance, and the only way to test, so everything that comes back from the user has to be validated on the server before you use it. You can't trust it. You should have logs on the server recording unexpected things from the client, so that if somebody tries some kind of attack involving sending many versions of modified data, you will notice it and log that this guy is obviously an attacker. They're trying to log in 1,000 times with the wrong password from the same IP address. We should really just not let them do that. After they get it 10 times wrong, we should block them for half an hour or something, and put them in the log. What's that?
They log your IP address, your internet provider.
Yeah.
And if your internet provider change, then they want you to reactivate or something.
That could
They
happen.
did that a couple of years ago. I guess people got annoyed.
Well, these days, that doesn't work because people are all on cell phones and moving from one place to another.
I know.
But they do now watch for suspicious countries. Like if you're in America and suddenly someone's logging in from China, they'll often warn you about that because that's likely to be a hacker. So this is a delicate art. And Allison Miller came here to give a talk. She does the security for credit card companies. And this is, see, in America, until recently, we had this ridiculous credit card system where you had a 16-digit number that you use the same number for every purchase, so every single person you ever use your credit card with can just keep taking more money forever. It's like you hand everybody you know a blank check. And that's insane, but they put all the defenses on the server side. Our only protection is the credit card companies are watching for suspicious transactions, and they got so good at
Code
it.
in the back of the credit card.
Yeah, but
they require sometimes.
Yeah, that'll help. But now the chip and pin, it's actually a different number every time. Chip without the pin, it's still not so good.
Oh, chip without the pin.
Yeah, it's not, but it's still better than it used to be. But but anyway, they are so good at it that they hold credit card fraud down to 0.5% in America, and they do it. And she's one of the people that does it by developing very clever algorithms to detect suspicious transactions. Anyway, that's all I had about that. Let me just make sure people are moving on the projects. I see people have done the first few projects. You've got the projects, I think, are the heart of this, where you do this stuff hands-on. So after command injection and SQL injection, you start using burp and zap. Down here, you map it. Here you made a Linux machine. We'll use it for tripwire. And down here is the defeating client-side validation with burp. That's what I demonstrated today. You defeat all those controls. It's very easy. And that's the point. Then I got more things, reCAPTCHA. And here's where we'll play with cryptography, where you replay tokens. Yeah.
Are the extra credits due at the same time as the normal project?
No, they're all not late until the last day of class. So I highly encourage you to do the extra credits. These things, you lose 5 points if they're late. These things are good until the last day of class. So I highly recommend them.
Yeah, we can try to fool Microsoft. There's the Windows 7 USB generator. Now, if your file isn't official long file name from Microsoft Download, it will not generate the USB. So there might be a way to fool Microsoft on the client side to see if it will still generate the USB stick.
There very well might be. I remember you.
I want to kill it.
I remember how you defeated BitLocker.
Yeah.
In the very early days, when BitLocker was new, Microsoft would not let you BitLocker encrypt your disk if it did not have a trusted platform module.
Chip. You need a chip.
You needed a special chip on if your chip wasn't there, and Kirk figured out you could just use a floppy, and it would just accept it and go. It's often the case that you can defeat their protection. I know another one was, I think I did that on my machine years ago. I put on a beta version of the Windows and then activated it as the full version. You can totally,
Yeah, you just changed the registry.
Yeah, you can, there's a lot of tricks you can play like that. Anyway, all right, any questions about anything? All right, well, I'll clean up and go up to the lab. Yeah, what's up?
So how many extra credit points do you have to earn to not have to take the final?
You can figure it out. This is a very popular thing. Most of my students do not take the final. You can see it up here, and there will be a chart down there. I don't have it yet.
And you can go to events.
The total number of points will be up here. It's not up here yet, but you just have to get up to 90% of the total points.
Okay.
And there's enough extra credit to totally get there. If you take the quizzes, and on the other hand, the final is a lot easier and less painful now that it's online and open.
Okay.
So more people might want to do it. However, you can totally just do extra credit. And if you do things like a CTF, that's off the map, and that's worth even more points. Okay. So, I mean, that's why there are people that do things that are not in my project, like this guy here. You can do something not in my schedule. As long as it's valuable, I don't mind giving you points for it. Go to conferences and stuff, yeah.
So what do you do to earn 400 points? I'm just curious.
Whole bunch of projects. This is a guy that's done this before. Take a class, do a whole bunch of independent projects that are not on my list, and it adds up to a lot. And when people got in CCDC and CPTC, they had hundreds of extra points. And if you do easy CTF and get a good score, it'll be worth a pile of points. And there's a whole bunch more after this one, by the way. If you like CTFs, which I highly recommend.
Hack this box. Remember, you're promoting Hack this box.
Yeah, Hack this box is very good, although it's pretty tough.
Up there as an extra credit.
Well, it's
I'm making a joke.
It's good, but it's beyond all my classes, that one. But anyway, there's a whole bunch of good CTFs. This one right now is running until 19th, and after that, there's another one called Angstrom coming up, and then there's another one called Are You Secure?
That's worth points if you go.
All these things are similar difficulty levels. easy enough that you can do them without knowing more than what I've taught in these classes, and they're all worth plenty of extra credit. So check them out, and NCL is fine too. That costs $25 or $35 to get in, and there'll be a contest in that, and that's a nationally ranked contest, so you'll probably be noticed if you're scoring well. So all these are good things, and they're all very good. They're all just a way to make it a little more fun to do the same kind of homework that I'd give you, but they're more challenging because you don't have instructions, and they really are somebody's idea of the latest, most clever trick. Beyond what you're doing here is standard stuff from a textbook that demonstrates a standard technique. These are somebody's idea of a newer, more exciting technique. Okay, so check them out. Do the CTFs. But if you don't want to do extra, you can just do the official projects.
There's an RSA conference that's worth points for going to it.
Yeah, and if you want to do that, you have to register as a student by April 1.
No, you have to register twice. Once as a guest, and you gotta go get a coupon,
And then
once as a student to get the 1 day free all access.
That's right.
So you have to register twice for the 1 day all access.
Good.
As a student, you have to register as a
and these
regular user for the
And this
coupon.
talk here is worth extra credit. Jenny's talk. I have this whole series of talks. Visiting speakers are worth extra credit. You can go to that if you like. Unless you're in CNIT 10, then that's the normal credit for it. But if you go to it and you're not in CNIT 10, it's worth extra credit. Same thing applies to other technical things like Pacific IT Pros.
B-Sides just opened up last
What's that?
week. B-Sides registration.
Oh, good. B-Side San Francisco? Yeah, and I'm going to be doing 2 workshops there. In fact, if you guys want to come help me, I'm doing 2 hands-on workshops at B-Sides, and I can use students to help as tutors. Usually I have several students, and if you do that, you get exposed in a public environment, and you can put like a profile on my page as my assistant, and that will help get you recognized in the community. So check it. I have several students doing that. They're going to help me they help me at DEF CON, and they're doing B-Sides Las Vegas, and Hope, and Circle City Con in Indianapolis. In summer, I'm going from conference to conference.
You got some free badges for those people who are assistants.
Yes, they get some free badges.
Those are $250.
I'll have either 3 or 6 free badges if they approve my workshops. And I give them to people who help me in my workshops, and after that, I give them to anybody who shows up. So they don't go to waste.